Dubai is a city built on an image of absolute perfection. Its towering skyline is wrapped in one of the most theoretically recyclable materials on Earth. The endless expanses of glass reflect the desert sun and project an aura of unstoppable economic momentum. But when one of these pristine facades is finally removed, its glass may never actually become glass again. It can be crushed, heavily contaminated, and buried quietly inside another construction material. The gleaming surface that once reflected an entire global metropolis simply disappears beneath an ordinary road. So where does the skyline of Dubai actually go when its buildings begin to age and die? The answer reveals a deeply complex vulnerability hiding behind the luxury tourism brochures. It is a silent collision between the environmental ambition of a modern city and the relentless economic pressure of maintaining a perfect image. The illusion of infinite growth is becoming harder to maintain. The first warning signs are not found in empty hotel lobbies, but in the hidden graveyards of architectural waste. Look closely at a single glass panel on the exterior of a luxury hotel in Dubai. For years, this component performed an absolutely impossible engineering task. It reflected the intense radiation of the Middle Eastern sun. It kept the heavily air-conditioned interior cold enough to satisfy demanding international tourists. It withstood extreme wind loads and the abrasive friction of seasonal sandstorms. Most importantly, it projected an image of flawless wealth and modern stability to millions of visitors. The entire economic engine of the city relies heavily on this visual perfection to maintain its status as a premier global destination. But the geopolitical and economic landscape of the region is changing rapidly. Regional competition for international tourists is accelerating at an unprecedented pace. Neighboring nations are pouring billions of dollars into their own futuristic megaprojects and luxury resorts. This growing regional instability in the tourism market means Dubai cannot afford to look old or outdated for even a single season. Hotels and commercial towers must constantly renovate their exteriors to justify premium room rates. They must maintain exceptionally high occupancy levels to cover their massive operational costs. When a building loses its pristine architectural appeal, the tourism revenue inevitably begins to face downward pressure. Hotel operators track their revenue per available room with ruthless precision. If that metric drops, the pressure to remodel and rebrand becomes an absolute financial necessity. Therefore, the beautiful glass facades are eventually stripped away and replaced with something newer. The very moment the crane removes that panel, its fundamental identity changes. Is it still a valuable architectural component? Or did it become a heavy liability the second it disconnected from the building? The obvious answer seems highly reassuring to anyone who cares about a circular economy. Glass does not rot in the sun. It does not rust in the humidity. It can theoretically be melted down and reformed indefinitely. But that simple answer hides the very first trap in the system. The panel has completely lost its high architectural value. It is now a heavy, incredibly fragile, and highly cumbersome piece of urban debris. The responsibility for its second life shifts away from the wealthy hotel owner. It is handed over to a complex and fragmented chain of demolition contractors. These contractors are operating under extreme time constraints, dictated by the tourism sector. The industry demands a fast replacement to minimize the time a hotel is closed to guests. The environmental reality requires a slow and meticulous dismantling process. These two opposing forces are fundamentally incompatible in a high-speed economy, and this is precisely where the perfect circle begins to break. The public understanding of material recycling is often dangerously simple. You drop a clear beverage bottle into a designated bin, and it magically becomes a new bottle again. The global flat glass industry operates on a very similar theoretical loop. Old glass can be mechanically crushed into small, uniform pieces called cullet. This processed cullet is then fed directly back into the extreme heat of a raw material furnace. Using this recycled cullet reduces the constant need for virgin silica sand. It also significantly lowers the massive amount of thermal energy required to melt raw materials. According to flat glass industry data from Europe, 1 ton of recycled glass can replace roughly 0.7 tons of virgin sand. This represents a highly efficient chemical process that saves both money and environmental resources. It makes perfect sense in a highly controlled, theoretical environment. Visitors to the region often look at the glittering towers and assume that the glass follows this exact logical path. They see a city that aggressively embraces futuristic technology and smart infrastructure. They naturally assume its waste management systems are equally flawless and completely circular. There is only one major problem with this incredibly comforting vision. The glass installed on a modern skyscraper is rarely just pure glass. It is a highly engineered composite material designed for extreme environmental performance. The simple and elegant recycling loop is entirely shattered by the sheer complexity of modern architectural design. The panel that was just removed from the luxury hotel does not belong in a standard melting furnace. It is an alien object masquerading as a simple sheet of pure silica. If it is treated like a common glass bottle, the entire industrial process will fail. The tourism industry demands buildings that perform like thermal fortresses. Those fortresses require materials that resist being broken down and separated. We must look closer at what exactly is hanging on the side of these buildings. From the street level, the facade looks like one perfect, seamless sheet of transparency. Underneath that stunning reflection, it is actually closer to a compact machine. Let us conduct a theoretical autopsy on a standard high-performance architectural panel. It is almost never a single, solitary piece of glass. It usually contains a thick outer pane and a specialized inner pane. Between these two panes lies a carefully sealed, insulating space. This space is often filled with argon or krypton gas to prevent thermal transfer. The exterior pane is coated with microscopic, invisible layers of metallic oxides. These metal coatings are specifically designed to aggressively reflect solar radiation. There may also be tinted layers to reduce the intense, blinding glare of the desert sun. If the glass is laminated for acoustic insulation or structural safety, the complexity increases. There is a thick, highly durable layer of polymer plastic bonded intimately between the glass sheets. Then you have all the structural elements required to hold this sandwich together. There are rigid aluminum spacer bars running along the edges. There are chemical desiccants hidden inside, designed to absorb any trapped moisture. There are primary sealants permanently holding the delicate edges. There are incredibly strong secondary structural silicone seals bonding the glass to the metal mounting frame. There are thick, weather-resistant rubber gaskets to ensure a perfect fit against the building. This entire complex assembly was engineered by brilliant minds to survive decades of structural stress. It was designed to endure thermal expansion, high winds, and building sway without ever coming apart. Now, the local recycling industry must somehow reverse this permanent engineering in a matter of days. Every single component that is not pure silica is a deadly contaminant to a new batch of flat glass. The advanced polymer, the silicone sealant, the metal spacers, and the solar coatings were never meant to enter the same furnace. But chemical complexity alone does not necessarily doom the panel. It still has a theoretical chance at a second life. It just has to survive the brutal, unforgiving reality of the first gate. The first gate is the physical demolition process itself. This is exactly where the financial pressure of the tourism economy directly collides with environmental sustainability. When a major hotel, luxury mall, or commercial center undergoes renovation, time is the single most expensive variable. Every day, a building is wrapped in scaffolding, is a day it is not generating vital revenue from international tourists. The financial imperative for the property owner is to complete the demolition phase as rapidly as humanly possible. In a high-speed demolition model, architectural glass is frequently treated as generic construction waste. The large panels are shattered quickly to remove them from the structural frame. The broken glass cascades down into massive, mixed waste containers. It instantly mixes with heavy concrete dust, broken ceramics, twisted metal rebar, and discarded drywall. Once high-value architectural glass shatters into 1,000,000 pieces and mixes with concrete, its closed-loop value drops to zero. It becomes almost impossible for a facility to identify the specific type of glass or its original chemical composition. The sustainable alternative is known as selective dismantling. This method requires specialized vacuum lifting equipment and highly trained crews. Workers must carefully detach each individual panel from the facade without breaking it. The intact glass must then be placed carefully on custom transport racks. It requires dedicated, specialized containers and significant on-site storage space. Most importantly, it requires exponentially more time and expensive manual labor. The demolition workers are caught in an impossible, highly stressful position. They are theoretically asked to salvage delicate materials for the environment. Simultaneously, they are ordered to complete the site work exactly on a punishing schedule. The tourism sector dictates the financial calendar, leaving very little room for meticulous material recovery. Suppose the panel miraculously survives this intense first gate. Suppose it is kept completely intact, separated from the concrete, and placed safely in the correct container. That tremendous effort still does not mean a flat glass furnace will automatically accept it. The panel is about to face an even stricter judge. The second gate is the absolute demand for chemical purity. A modern flat glass production furnace is an incredibly sensitive and volatile industrial environment. It operates continuously at temperatures exceeding 1,500 degrees Celsius. It relies on a perfectly balanced mixture of materials to produce a continuous ribbon of flawless glass. The automated quality control systems inside these facilities do not recognize a broad, friendly concept like recycled material. They only see specific chemical compositions and the potential for catastrophic defects. If a single, small piece of ceramic or stone enters the furnace with the crushed glass, it will not melt properly. It will create a microscopic, hard flaw in the newly formed glass ribbon. This tiny flaw can cause an entire massive production batch to shatter spontaneously on the cooling line. If heavy metals from the old building sealants enter the molten mix, they can permanently alter the color of the final product. Therefore, the industrial tolerance for contamination is virtually zero. The processing facility must find a way to strip away every single trace of silicone, rubber, and aluminum. They must accurately separate different colors of glass and sort out different types of advanced metallic coatings. This is an extremely difficult and expensive technical challenge. To understand the sheer scale of this barrier, we can look at established international benchmarks. Glass for Europe formally estimates that around 1.5 million tons of end-of-life building glass is generated in the European Union every year. Despite having advanced infrastructure and strict regulations, only about 5% of that glass finds its way back into new flat glass production. That is merely 5% that actually survives the rigorous purity test. This is absolutely not a specific statistic for Dubai. However, it powerfully highlights a universal, systemic failure across the entire global construction industry. And even if the glass somehow achieves perfect chemical purity, the journey is not over, because absolute purity does not automatically pay for the transportation truck. The third gate is the crushing, undeniable reality of logistics and economic feasibility. A material can be perfectly recyclable in a chemistry laboratory, but it will not be recycled in the real world if the economics fail. This may be the most uncomfortable part of the entire investigation. Let us build the basic economic equation for our surviving glass panel. The financial costs begin to accumulate, the very moment the crane is deployed. There is the premium cost of selective, slow manual dismantling. There is the cost of specialized labor required to cut away the stubborn silicone and separate the aluminum frames. There is the ongoing rental cost of dedicated transport containers. There is the cost of secure storage in a city where commercial real estate space is exceptionally expensive. Then comes the substantial cost of safe transportation to a specialized processing facility. Architectural glass is incredibly heavy, very fragile, and takes up a massive amount of volume on a truck bed. Once it finally arrives at the facility, there are significant operational costs for industrial cleaning and advanced optical sorting. The facility will inevitably reject a large percentage of the incoming material if it does not meet the strict purity standards. Finally, there is the strict requirement for massive minimum volumes to make the entire process financially viable. On the other side of this daunting equation is the price a flat glass manufacturer is actually willing to pay for the clean cullet. If the total accumulated cost of dismantling, transporting, and cleaning exceeds the market value of the recovered glass, the loop breaks instantly. The financial spreadsheet ultimately decides the fate of the physical material. This is where the broader economic vulnerabilities of the city become highly relevant. When hotel revenues face seasonal drops, the profit margins tighten. When increased regional competition forces airlines and tourism boards to lower prices, the overall economic pressure mounts. Under these strict financial conditions, the generous budget for expensive, sustainable demolition is often the first thing eliminated. The current economic structure of the construction industry actively discourages closed-loop recycling. Yet, Dubai appears to fully understand this exact problem. In fact, the city has created detailed administrative systems for managing and tracking its waste. Dubai has actively established detailed frameworks for managing urban waste across the emirate. The Dubai municipality provides specific technical guidelines for glass waste processing. There are comprehensive, documented rules for construction and demolition waste recycling. The city operates official weighing stations, issues transportation permits, and carefully tracks the flow of materials. Official long-term strategies, such as the Dubai Integrated Waste Management Strategy, set highly ambitious targets. They aim to divert 100% of waste from landfills by the year 2041. A significant portion of this diversion is meant to come directly from recycling efforts. For a brief, hopeful moment, it looks as if the policy has successfully solved the physics problem. A city can meticulously track a ton of glass from a recently demolished hotel. It can weigh the truck at a designated checkpoint. It can confirm that the material safely entered a licensed processing facility. It can even issue a formal certificate stating the waste was successfully diverted from the landfill. But none of that bureaucratic tracking guarantees the glass will ever become glass again. This brings us to a critical distinction that the real estate industry rarely discusses openly. There is a massive, fundamental difference between closed-loop recycling and downcycling. Closed-loop means the old facade becomes clean cullet, enters a furnace, and is reborn as a new transparent window. Downcycling means the glass is mechanically crushed into low-grade aggregate. It is mixed into heavy concrete blocks. It is used as a foundational base layer beneath a new highway project. Downcycling is certainly better than dumping the material directly into a desert landfill. It provides a useful secondary function and replaces some virgin construction materials, but it is the absolute end of the line for the glass. The material has not completely vanished from the city. Its high-value identity has simply disappeared forever. We must now leave the recycling facility and look at the broader implications for the entire region. This is no longer the isolated story of a single panel from one renovated hotel. The next time you look at the glittering skyline of Dubai, try seeing it completely differently. Do not look at it merely as a collection of permanent luxury destinations and residential towers. Look at it as millions of engineered components temporarily stored above the ground. The entire skyline is an unfathomably large, temporary material bank. Over the coming decades, the intense pressure of the tourism economy will demand fresh aesthetics. These aging facades will inevitably come down to make way for the next architectural trend. Across decades of replacement, renovation, and demolition, thousands of tons of architectural glass could eventually enter this vulnerable system. The sheer volume of material waiting in the sky is mathematically staggering. Dubai has already proven to the world that it can build one of the most spectacular skylines in human history. The much harder engineering problem may be learning how to take it apart safely. There are theoretical solutions currently available to the global industry. Developers could conduct comprehensive material audits long before any demolition begins. They could implement strict, mandatory selective dismantling protocols for all major renovations. Global glass manufacturers could establish regional take-back systems, guaranteeing they will purchase the clean cullet. The industry could design future facades specifically for disassembly, using reversible adhesives and standardized material passports. International examples demonstrate that closed-loop recycling is technically possible when all parties collaborate properly. But all of these potential solutions require someone to aggressively protect the value of the glass before it becomes waste. They require a fundamental shift in how the construction and tourism industries view their own buildings. The glass graveyard of Dubai may not look like a traditional graveyard at all. It may look exactly like an ordinary road surface carrying daily traffic. It may look like contaminated fragments hidden deeply inside a massive, forgotten demolition pile. It may simply look like a digital certificate showing that a ton of material was recycled, without ever revealing what it actually became. The fundamental chemistry of glass allows it to live and be reborn infinitely. The complex economic and logistical systems built around it decide whether it actually will. Dubai proved to the entire world that a harsh desert could be successfully wrapped in endless miles of glass. Its next great test is whether that glass can ever find its way back home. The pressure to maintain the perfect illusion is heavy. The cost of that illusion is hidden quietly in the broken loops of its own materials. This documentary examines the technical and economic barriers to closed-loop recycling of architectural glass. It does not claim that all glass waste in Dubai is landfilled or that no recycling infrastructure currently exists. Where international data is used, it is clearly identified as a comparative benchmark rather than a Dubai-specific statistic. This video analyzes broad industry systems, economic pressures, and environmental trends. It does not constitute financial, investment, or travel advice. Economic conditions, tourism metrics, and urban waste policies are subject to ongoing development and change. When a luxury building is proudly marketed as highly sustainable, should its end-of-life demolition plan be fully disclosed on the day it is built? Tell us what you think in the comments section below. Please subscribe as we continue investigating the hidden economic systems and environmental realities beneath the global skyline. The next warning sign is rarely where the official brochure tells you to look.